What's up, guys? It's Chemical Engineering Guy, and we're going to take this mass balance course to see the topic on diagram and flow construction. Diagram flow construction. In general, it's how to construct a diagram that shows all the flows, process units, and essentially how to do it. So, before, probably you've seen, we saw three examples about the distillation unit and about mixing unit, and I think the last one, it was a semi-batch. It was about a tank that was evaporating hexane. So if you haven't seen those, please go, it's one video before. You will understand the need of the construction of diagram flows, and these are just like general rules how to do diagrams. So let's do it. It's so easy to construct. Just go to the basics and you will never get lost, because we need actually like a standard to know when are we, that you can read someone else's diagram, you can go to internet and understand the diagram, etc. So in general, you will see a text so telling you all the problem, like a verb. They will see you evaporate, you dehydrate, blah 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 blah. All these things are not that useful, or at least I think it's more useful if you organize the data and then draw it, like draw an actual diagram. I think it's better to see, if I tell you there's like this here and I fit it here and then it goes here, I think it's better than just tell you like there's a column about, I don't know, 50 meters and you need an inlet here, and we're not going to do that. Well, actually we are going to do that, but what we are going to do is to draw that concept. Now, we're going to treat these unit operations, for example here, this distillation unit or dehydrator or whatever it is, we're going to take it as a unit operation and we're going to call these boxes. What is a box? Is nothing more than a block which represent a unit operation. The flows or streams will be the arrows showing the direction of the flow. It doesn't matter the size or direction of flow, just, of course, that if you connect one arrow to a box, you're saying it is going inside, and if you connect an arrow to another thing like disconnected, you are telling them that you are not having an inlet but an outlet. So doesn't matter the size, doesn't matter the width, doesn't matter the length, etc. You just need an arrow to show the direction of the flow. Normally we're going to label up here the name of the flow, F, with the total if you have it, and down here we try to use the composition of the flow, doesn't work that much. The composition of the flow, so you have, for example, water, sulfuric acid, and table salt. Just look, what is this? This means weight of water per weight of solution or mixture, whatever you want. What does it mean is this is mass fraction, because sometimes you will have mole fraction, so it's not the same, you gotta change it. And right now we don't take care about temperature and pressure, but in chapter 5 you will actually need the temperature and pressure, especially if you are dealing with gases. So guys, let's continue. The general rules that I recommend is taggage, equipment, and arrow. So don't let just flows everywhere. And sometimes like this flow actually is important. It connects. Why just let it here? Why don't label M1, M2, and M3? Or equipment, don't let blocks alone, please. You are mixing, there's always a mixing unit. Even though it's like piping, but there's something special there mixing. Please assign variables to the unknown. If you don't know that, just assign it as a variable. You have airflow, just tell F. You don't know what is it, just leave it alone. You have this data, just write it down. Avoid excess of variables, please. It will help you a lot. For example, if they tell you C is the half of the inlet F, don't use C, just use half F. For example, I have this, I have F, C, and D. Why use C when we can use 1/2 of F? It's better, I think. If you can do it, okay. Or if they tell you A is equal to the flow of the distillate, which doesn't make sense, but okay, if they tell you E is equal to D, you could actually say E is equal to E, which or to D, and D. You just have one variable instead of two. So okay, avoid excess of variables. Use the same units to avoid error, confusion, and conversions. So I rather convert everything and then write down in the stream than having the stream with, I don't know, moles and the stream in pounds and mass, like kilograms, tons. So I rather do everything before, and I don't know, if I'm working with kilos, I write down kilo. If I'm working with tons, I write down ton. You have the data in grams, I need to change it to tons. I have the data in pounds, I need to change it to kilograms.